So let's look at that last bit of 6, 7. Leading up to 6, 7, leading up to this point right now, I've been training you guys in my own way, believe it or not, setting you up to make this really easy. For example, yeah. Sweep the leg, Johnny. Am I ready too fast?
Yes. It's words.
No, because you stopped. Yeah, you stopped this time before. You kept going.
We've been asking this all along. If 3 is your 0, what was your term?
Negative 3.
X minus 3. Your term was x minus 3. If 6 was your 0, what was your term?
X minus 6.
If negative 7 was your 0,
X plus 6.
x plus 7. So if your 0 was negative 7, you'd write it as x minus negative 7. You turn it to x plus 7. Well, not 5. Okay? You did that. All along, I've been talking to you guys about the relationship between zeros and terms. Well, today, you're going to write the polynomial given the terms. Okay? We're going to write the polynomial given the terms. So if I say your zeros are at 3, negative 4, and 5, we're going to write the polynomial of least degree. What that means is, if I have 3 zeros, what's the smallest degree that I can have? 3. Okay. I'm going to write a third degree polynomial that has those zeros. So if 3, negative 4, and 5 are my zeros, what are my 3 terms?
Wait, 10 minutes. So if there's
X plus 4 and X minus 5.
there's not 3 zeros, it can have more than that.
If they're real, if I'm just giving you 3, you can have a fifth degree with 2 imaginaries, things like that. But we'll get into the imaginaries in a little bit. For right now, we're just going straight. If you have 3 here, you're going to have 3 terms. What were my terms again? I'm sorry.
X minus 3, X plus 4, X minus 5.
And then I would just FOIL it all out and rewrite it. So I get x minus 3, x squared minus x minus 20. And then I would send that through one more time. When you write your polynomials out, make sure you always write them in a descending order. We're also assuming in this case that our first leading term coefficient is going to be 1. We will talk about that being different in, is it 6-8? Either 6-8 or 6-9. We're going to talk about that first term being different. We'll worry about that when that comes up, because it's a different way to do it. So you get x cubed minus x squared minus 20x minus 3x squared. What? I wrote 3x squared.
Why is it minus X?
No, he's not counting.
I just go like X and then X squared and then Cooper.
Whatever. Combined like terms, you should get x cubed minus 4x squared minus 17x plus 60. So in this case here, you wouldn't be able to group it because you'll notice that the last 2 terms don't have GCFs that are going to work.
Wait, that's really easy.
What's up?
They're all
Well, that's just when you have real solutions.
Yay.
Because what happens now is, if you have this, 2 and an I,
X squared.
X squared plus or minus 1.
here's what's going to happen. If you have one of the I values listed as a 0, you have to have the other I value. In this case, I said that you have a positive I, which means you should also have to have a negative I. A lot of times what they do is they don't list it. They just list one of them. Because think about the order to get a value of I, that means you had to take the square root of some negative number. When you take the square root of a negative number, you had plus minus. Because that's how you solved it. When you took the square. So what's going to happen a lot of times is that they might only list one of the imaginaries. So you have to write out the other one. And I'm going to show you this long form as far as how this is going to work when you have I values. We all agree that our first term here is going to be x minus 2.
Yes.
Okay with that?
Yeah.
Now, when we say that these are my zeros, remember, this is x minus I, and then x minus the negative I. You agree with that? Which means this one is, when you FOIL that out, you wind up with a difference of squares, because the middle term will go away. Ready to see that? So here you wind up with x squared minus I squared, which is x squared plus 1. So you have x minus 2 and x squared plus 1. Those wind up being your two terms. Yes, sir?
So like I noticed in the homework when we were doing the, like, it was like 27, 28, and 29.
Yeah.
It had that kind of thing, and that you can, like, I kind of figured out an equation in my head to, like,
When it was like x squared plus 9, you knew it was x, you knew your zeros are plus minus 3i.
yeah.
Yeah, and that's fine. I'm showing you how that, why that works.
Okay.
Okay. Yes, ma'am?
I squared is negative 1, right?
Yep. So that's why I wrote x squared minus negative 1, I get plus 1. So now from here, I've just FOIL this out and rewrite my polynomial. X cubed minus 2x squared plus x minus 2. And that would be my polynomial.
Well, you said x cubed.
Yeah, oh, sorry. There. I said it.
Yeah, I always thought I was going crazy.
I was half right. Or 2/3 of the way there. Very excited. Let's try another one. Say I give you two zeros, negative 3 and negative 4i. What's missing? Plus 4i, good. Which means, when you write it out, you have x plus 3, x plus 4i, x minus 4i. Do you remember what function gives you zeros at plus minus 4i? X squared plus 16. And then FOIL out. We do this, we get x cubed, 3x squared, 16x, and 48. The weirdness comes in when we have conjugates. The weirdness is going to come in when we have this. Let's see, let's do 1 and 2 plus 3i. So if I have a 0 of 2 plus 3i, what would the other 0 have? It would just be 2 minus 3i. Okay. The missing 0 now is 2 minus 3i. And I'm going to write it out long form again. And this is going to take a minute or two to see what's exactly happening. First one's pretty simple. 0 is 1, term is so that's easy. Now, long form means I'm going to write it as x minus 2 plus 3i. Because that's what that meant. X minus 1, x minus the 0, x minus the 0. What's out in front of the, what's out right here that you don't see? A negative 1. So what, in essence, what I'm going to do here I'm going to distribute this -1 to both parts and rewrite it. I'm going to get x minus 2 minus 3i. And then on the other one I get x minus 2 plus 3i. Here's a nice trick. I'm putting a little bracket around that first grouping of x minus 2 on both parts. And the reason I'm doing that is because I'm going to do this next step. I'm going to let a equal x minus 2 and b equal 3i. This will probably be the only time that I actually write out this what's called a use substitution step. I'm taking something that looks awful and using something very easy to represent it. Because watch what happens when I do that. I get difference of squares. A minus b, a plus b. See how that looked out? And when you have a difference of squares, all you're doing is you get a squared minus b squared. And what did A represent? And what did B represent? So you get x minus 2 minus what's going to happen here is if you FOILed this out, you multiply this here, you multiply this here, here, and here, those middle terms drop, don't they? The middle terms still drop, and you get the quantity x minus 2 squared minus the quantity 3i squared. You get the same idea, but you're using this little shortcut here to show that it works. You don't have to write that step out. Really, the biggest trick is remembering to distribute this negative to both parts. And when you do that, you're going to get a difference of squares. First term squared minus second term squared. Works every single time. X minus 2 quantity squared is not x squared plus 4. The 4 puppies.
It's x minus 2 times.
What is 3i squared? Negative 9. Minus a negative 9. Because 3i squared is 3 squared and I squared. So it's 9 times negative 1, so it's negative 9. So you wind up with x squared minus 4x plus 13. And the other one was way back up there as x minus 1. And what do you think I have to do to finish that out?
We'll find zeros.
No, we already had the zeros, just distribute. Just distribute and be done. Okay. The idea is this part here, where you guys have to remember to distribute out that negative. That's the trick. And once you distribute that negative, the problem falls into play the exact same way as everything else does. First term squared minus last term squared. And do not kill the puppies. Puppies are friends. Okay? Let's try another one. Then I'm going to do the same thing with the radical. It works the same way with radicals like that as well. So if I have negative 2 and then 1 minus 5i, what's the missing 0? 1 plus 5i, good. So we're going to have an x plus 2. I'm just dropping into the idea it's x minus whatever the 0 is, x minus whatever the 0 is. Distribute out that negative. We're always going to get what's that? Oh, sorry, I just didn't write it down. My fault. Thanks, Melissa. And notice how you wind up with that difference of squares again. Now, 5i times negative 5i is, so we get minus 25i squared, which is 25. So you wind up with x plus 2, x squared minus 2x plus 1 plus 25. Yeah, 26. And then I'll let you guys finish that. Yes, sir.
Is there supposed to be like a bracket on the end of the other? I didn't know if that's what.
Yeah. To be honest with you, if you forget it, isn't really that big of a deal. It really isn't, but I see what you're saying. I should make it look right.
Ooh, guys, there's reports in here.
Why the long face?
I hate that.
Get it? Worse.
Serious.
Wow. Ouch.
Are you happy we're doing that?
Yay. All right. Before we get out of here, I want to show you the same basic idea if you have radicals. Works the exact same way. You have conjugates with radicals. All right. If you have zeros of 2i and 2 minus the square root of 3.
Okay.
What are your other zeros, 0 and or zeros that are missing? 2 plus root 3. I'm missing a 2 plus root 3. And a negative 2 I get. What happens in order for you to get the square root, if you got a square root in an answer, you had to take the square root over equal, and that's where you have 2. You always get 2 of them. So what is the term that gives you plus minus 2i as your solution for zeros? X squared plus 4. Good. So you know one of these has to be x squared plus 4. And now the other 0, I'm going to do the exact same thing as what we did a second ago with the plus minus I stuff. I can still write that out as x minus the 2 minus root 3 and x minus the 2 plus root 3. I'm still going to go ahead and distribute my negative. And I'm still going to get that first term was going to be x minus 2, and then the last one's going to be plus and or minus the root 3. Yeah.
Where are you getting x squared plus 4?
When I had the zeros of plus and minus 2i, the only way I can get that is if my term was x squared plus 4, because here I subtract 4 and take the square root.
But that's why it works?
Yeah. Your zeros become plus or minus 2i. Well, think of it this way. In order to get I, you had to take x squared equals negative 1, right?
Okay.
Whenever you have plus minus, if it's just a 2 and an I squared, it's x squared plus that. If you had a 0 at 4i, it'd be x squared plus 16. That's all. It's a shortcut. Here you wind up with x minus 2 plus root 3, and then x minus 2 minus root 3. And then you'd FOIL that one through as well. It's actually a little bit easier because you wind up with what's root 3 squared? 3. So your solution winds up down here is x squared plus 4. X squared minus 2, or x minus 2 quantity squared is going to be x squared minus 4x plus 4. FOIL that out, you get minus 3. And then you just combine them out. And then go through that. I wanted to show you the radical one because it does show up from time to time. It's the same exact process. It's the exact same thing that you do. Okay. And then it's just a matter of FOILing out your 4th degree polynomial. And go from there. All right? Help yourself, man. They're right back there. Sign one. Go ahead and sign out. Would you flip to the right behind you? Many instructions. All right. They give you a couple of these for tonight.
This isn't okay. Why is this a thing?
What I want you to do on here is the 6, 7 stuff.
All of it? Yes, please.
Okay, there. The 6, 7 stuff, I'd like you to do 19 through 29.
Well, that's 11 problems.
The 6, 7 side, 19 through the 29. What's that? And then you'll notice where it's saying find all zeros. I'm seeing 1, 2 of them right off the bat that I know I can group. One of them I can get back to the way it sits. And there's a couple of them that you're going to have to actually go through your zeros tests. Okay? All right? What's up, Shiki?
Do we have to come to both meetings this week?
No, you'll be all right. I mean, yeah, ideally I'd like that. But
My people down by the doctor. You asked for crate 36. Not in my doctor.